We've been asked to find the equation line to the tangent of the curve f of x equals x squared plus 1 at the point where x equals 3. So is it nice to know what this looks like? Surely. Here's our curve. F of x equals x squared plus 1. And here's the spot where x is equal to 3. We can see that our tangent line here is going to go something like this. Now, why is this nice to know? Because if we know the tangent line looks like this, we can anticipate its rise over run, or in other words, m tangent, should be positive because this graph goes up and to the right. So we're going to do this via first principles or using the difference quotient. If f of x equals x squared plus 1, then f of 3 equals 3 squared plus 1. We have to follow parentheses, exponents, multiplication, division, addition, subtraction with all problems like this. So 3 squared is 9 plus 1 is 10. F of 3 equals 10. We must understand that this means when x equals 3, y equals 10. To give us a point, 3, 10. This point will be important for us to be able to find the actual tangent line slope, not the slope so much, but the equation y equals mx plus b of this red line that I've drawn here. All right, well, how do we find the slope of this tangent line? We know m tangent is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. This, of course, is what we call the difference quotient. You are expected to come to any kind of assessment knowing this formula. If you don't know it, drink it in with your eyeballs now and study it. This is where it comes from. You saw where it came from. So it shouldn't be a mystery or extremely difficult to commit this to memory because it makes sense. It's simply slope. So the easy part of this, given as a reminder that f of x is equal to x squared plus 1, the limit as delta x goes to 0 of, well, this part is easy, minus f of x, and this part is easy, delta x. They've given us f of x, x squared plus 1. The harder part will be figuring out what is f of x plus delta x. Well, f of 9 is something squared plus 1. If I do f of 9, I put a 9 in there. F of 19 is something squared plus 1. I'm going to put a 19 in there. So if I have f of x plus delta x, that's something squared plus 1. The pattern continues. And this is going to be x plus delta x. So I get x plus delta x squared plus 1. I must nail that. What is that? That's the function value at x plus delta x. That seems to me the hardest part of this process is figuring out what is f of x plus delta x. Now be careful. You've had pre-algebra. You've had algebra 1. You've had algebra 2. You should not deal with this incorrectly after all that experience. You know what to do here. You have to FOIL this out. By the way, I'm going to distribute this -1 to get plus 1. That comes from there. And then I'm going to have negative x squared minus 1 all over delta x. And I'm taking the limit as delta x goes to 0. Do you ever forget that, Mr. Curran? No, I don't. If I mean to take the limit, I write it. I don't get lazy, and I don't forget it. And before I hand in a test or an assessment or a quiz, I always make sure, have I crossed all my T's and dotted all my I's? This part of this equation is what I'm going to FOIL. I'm going to FOIL this out. So I get the limit as delta x goes to 0 of x squared plus inner x delta x, outer plus x delta x, last plus delta x, the whole thing squared, plus 1 minus x squared minus 1, all divided by delta x. Now, I can already tell you we're going to have some cancellations. I see plus 1 and minus 1 cancel. I see x squared and minus x squared cancel. So I can simplify this to the limit as delta x goes to 0 of 2x delta x plus delta x squared divided by delta x. Many students have trouble with this. Think of this as a truck. One truck plus one truck. One truck plus one truck would be two trucks. Think of it as a tree. One tree plus one tree would give you two trees. Think of it as a dog. One dog plus one dog would be two dogs. So what if the dog's name was x delta x? One x delta x plus another x delta x would give you two of these beautiful x delta x's. Isn't it tempting? Isn't it so tempting to say, well, these will cancel. And now, well, we can't do that. We know that if we have, let's go back to algebra, A times B over A. If you cancel this, everyone is happy. I'm happy. You're happy. Those aforementioned dogs are happy. But if you have A plus or minus B over A and you cancel these, everyone is sad. Now, why is that? If I have, let's go 5 for A and 10 for B. If we have this, we know that the answer here is 10. 50 divided by 5 is 10. So if I cancel these, I still get 10. But if I do 5 plus 10 over 5, we know the answer is 5 plus 10 is 15 divided by 5. This is true. But if I cancel these, then I get 10 equals 3, and that's what makes us sad. It's not just the making up rules. It's that the rules are based on numbers. So you can't cancel until after you've factored. Luckily, we see that if we factor out a delta x, we're left with 2x plus delta x over delta x. Let's see, is it true? Delta x times 2x is 2x delta x. Delta x times delta x is delta x squared. So we are good. But do you always check your math like that? Yeah, I sure do. Notice if we did direct substitution at this point, we'd still get frustrated with this indeterminate form. If we did direct substitution at this point, we'd still get 0 over 0. It's right now, after we cancel, that the magic starts to happen. Is that San Francisco? Is that Jimmy G? Is that the Golden Gate Bridge? Jimmy G's on Vegas now, I know that. No, that's the mighty cockroach. After our next nuclear apocalypse, what will survive? The mighty cockroach will survive. That's not San Francisco. That's the surviving function. So when you do direct substitution, you're going to get this, which is equal to this. So we can say f prime of x, which we know to be m tangent, is equal to 2x. This gives us the slope of the tangent anywhere. We wanted, because it was stipulated in the problem, it has to be given to us. We were interested, we take our black cobalt eyeballs, we're interested in looking right here when x is equal to 3, and we're anticipating a positive slope. Well, we saw that f of 3 equals 10 means when x is 3, y is 10. Now, we're doing f prime of x equals 2x. So f prime of, plug it in, 3 is 2 times 3, which is 6. Every time, without fail, when I find the derivative at a specified value, 3 in this case for x, I write this. I write m tan to remind myself that I just found the slope of the tangent. Well, if I have 3, 10 as an xy point, and I've got a slope of 6. One method would be to find y equals mx plus b by saying y equals mx plus b and doing a triple substitution to solve for b. We know that y is 10 when the slope is 6 and our x is 3. So simple algebra, minus 18 on both sides, gives us negative 8 equals b, which is our y-intercept. Now that we've got slope and y-intercept, we can say y equals mx plus b becomes y equals 6x plus a negative 18, or simply 6x minus 18. That is the equation of this line here. We just found that this is y equals 6x minus 8. Notice that we're expecting down here to have a y-intercept that's negative, and our rise is 6 when our run is 1. So when we get that and it meets our expectations, we, again, are super happy. Don't like that? 0.3 comma 10 and a slope of 6. You could also go to point slope form, which is y minus y1 equals m times x minus x1. In this case, you have to understand that the point you found will now be designated x1, y1. So y minus 10 equals 6 times x minus 3. Also a fine answer. I actually prefer the y equals mx plus b slope-intercept form because it allows you to check your preconceived notions about the line.